Hey Poema, I have your quiz here. Sorry for the delay. So this lesson or quiz is all about experimental versus theoretical probability. And so theoretical probability is what we expect or think would happen. For example, if you tossed a coin, the theoretical probability that it lands on a head or a tails is 50-50 or 1/2. Experimental probability is what happens when you actually do flip the coin, right? Let's say you flip the coin 10 times or 20 times and you record what happens. That's your experimental probability. So the first question asked or stated that Nathan rolls a number cube, records the results, and here they are on the table. And then it wants to know which of these statements below are true or represent the situation. You were supposed to pick 3 of them. So what you can see is that you picked this red X and should have picked this gray check mark. Same thing here, you picked the red X and should have picked the gray check mark. So let's talk about why the gray check marks are correct. It says the experimental probability of rolling a 2 is greater than the theoretical probability of rolling a 2. So when we're talking about a number cube, the theoretical probability of rolling any of the numbers is 1/6 because each number appears 1 time and there are 6 of them, and each number is equally likely to be rolled. So in the table, we have to figure out what was the experimental probability. And so I didn't see if above it says, yeah, it didn't say how many times he rolled the cube, so we're going to have to count that to start. So I'm just going to add this whole frequency column because these are that's the number of times he performed the experiment. So 11 plus 16 plus 14 plus 20 plus 12 plus 17 is 90 times. He rolled the cube 90 times. And this one was about rolling a 2. So he rolled a 2 16 out of 90 times. So if we reduce that, both of these are divisible by 2. That's 8 over 45. And so 8 divided by 45 is 0.17 repeating. And then again, that 1/6, which is the theoretical probability. If you do 1 divided by 6 in a calculator, you get 0.16 repeating. So you can see that what happened in the experiment was greater than what we expected to happen. So he rolled a 2 a little bit more than we might have expected. And then in the next one, the experimental probability of rolling a 1 is less than the experimental probability of rolling a 6. So this is not true. This is both experimental probability, and again, the experimental probability of rolling each one of these numbers is 1/6. So you have a 1/6 chance that you roll a 1, and you have a 1/6 chance that you roll a 6. Question 3 says 4 students are determining the probability of flipping a coin and it landing heads up. Each flips a coin the number of times shown in the table. Which student is most likely to find that the actual number of times his or her coin lands heads up most closely matches the predicted number of heads up landings? So this question, all it really has to do with is how do we get closer to the actual theoretical probability. And so again, for it landing heads up, it's a 50-50 chance, or 1 out of 2, right? 1 out of every 2 flips it should land on heads. That's a 50% chance. So the question is, who would get closer to actually it being 50-50? And in this case, in all of the cases like this, it's the student or the experiment that happened the most times. The more times that you execute or do an experiment, the more likely you are to get close to that actual experiment, right? I could flip a coin twice and it could land on tails both times. 0 is a heck of a lot less than half, which is what we were expecting. But if I flip a coin 100 times, it's going to be much closer to that 50% than if I just flip a coin twice. So this one is Colin, and it's because he performed the experiment the most number of times. James conducted an experiment with 4 possible outcomes. He determined that the experimental probability of event A happening is 10 out of 50. The theoretical probability of event A, happening is 1 out of 4. which action is most likely to cause the experimental probability and theoretical probabilities for each event in the experiment to become closer? I would guess that he needs to do it more times, but let's see. Removing the last 10 trials, no. Completing the experiment many more times and combining the results to the trials already done, including a fifth possible outcome, performing the experiment again, stopping immediately after each event occurs once. No. So again, this is kind of like that last question. The more times you do the experiment, the closer you should get to the theoretical probability. So what happened was experimental probability was 10 out of 50. And theoretical is 1/4. So that's 25%, but 10 out of 50 is 20%. So we're trying to figure out how do we get these two numbers to actually be closer, and it would be to perform the experiment many more times and combine all the results. Might conduct an experiment by flipping a fair coin 200 times. They say a fair coin, that just means it's not weighted. It's equally likely that it lands on heads, and it's equally likely that it lands on tails. The coin landed heads up 110 times. Which statement about the coin landing heads up in Mai's experiment is correct? So again, if we do it 100 times or 200 times, we are expecting, or in theory, 100 of them should be heads and 100 of them should be tails. So the experimental probability of the coin landing up is 11/20. So if you take 110 out of 200, right, I can divide by 10 on both of those, I get 11/20. That is the experimental probability. Theoretical probability is 1/2. That's also right. So it's the second one here. Remember, experimental probability is what happened in the experiment, and that is not what happened in the experiment. The experiment was 110 out of 200. Which reduces again to 11/20. Frederick designed an experiment which he spun the spinner 20 times and recorded the results of each spin. He spun a 4 5 times. Which statements are true? Check all that apply. So 20, he got a 4 5 out of 20 times. So we divide, that's 1/4 of the time. And that's way more than we would expect it, right? So there's 10 spots here, and they're all equally likely to occur because they're all the same size. I haven't even read any of this yet. We would expect all of these would have a 1/10 chance, every one of these, right? Because there's 10 of them. Each one is equally likely to occur. And so you ended up getting 1/4. That means it landed on a 4 way more than we expected. So for the experimental outcomes to be closer to the predicted, the number of trials should be increased. Again, that's kind of going back to these other questions. The more times you do it, the more likely you are to get to that 1/10. So if you spun this 20 more times, it's probably not going to land on a 4 that many because it's already landed on 4 so many times. So it'll be less as you go to get that closer to 1/10. If the number of trials is changed, the experimental probability also changes. Yep, absolutely. So if we spin it just one more time and it doesn't land on a 4, now that's 5 out of 21. So it's not 1/4 anymore. And I'm just reading the right ones, the correct answers. If the number of trials is changed, the number of experimental outcomes also changes. Yeah, so that's, again, that same experimental outcomes is what happened in the experiment. So yes, you're changing those numbers as well because it's landing on other numbers as you continue to spin. Theoretical probability will never change because it's in theory what we think should happen. Again, each of these spaces is a 1 out of 10 chance or a 10% chance. Theoretical probability does not change. Josh used a standard deck of 52 cards to conduct an experiment. Half of the cards in the deck were red, the other half were black. So it's 50-50. Josh predicted that he would choose a red card in 4 out of 8 trials. That's also 50-50. When he conducted the experiment, he actually chose a red card 6 out of 8 times, which explains the most likely reason. And I haven't read these yet, but I guess it's going to say something about he didn't do it enough times. He incorrectly predicted. Nope, if it's out of 8 and it's 50-50, 4 out of 8 would be 50-50. He incorrectly determined the actual number of times he chose a red card. I mean, I doubt it. He says he got a red card 6 out of 8, so that's counted correctly. He used too few trials. Oh, yep, here we go again. So there's that concept that he just didn't do it enough times to truly get to 50-50. The more times you do an experiment, the closer you get to that theoretical probability. So there was kind of a common theme in the questions that you missed. Again, that it's more about theoretical probability is what you think will happen. I flip a coin, I think I will land on heads half of the time, and I think I will land on tails half the time, because, right, there's just two sides to a coin. On a number cube, a die, it's 1 through 6, so I have a 1 in 6 chance of it landing on a 2, or any of the numbers. And so again, when we start performing these experiments to see how close are we to that theoretical probability, you just have to do the experiment more times. If you're not close, the more times you repeat it, the closer you will get to that theoretical probability. Sorry for the delay on this again. Please let me know if you have any questions, and I'll get back to you as soon as possible.